Assalamualaikum and good morning, class. Okay, I think we only have how many of you? 2, 4, 5. Okay, we'll wait for about 2 or 3 minutes. Okay, I think we can start now. As long as group 9 and 10 are ready. Just now your friend for group 9, Afifah Anissa. Afifah Anissa is not around because she has another class to attend to. So do you mind if only Ashraf and if only Aizat and Zazmizul present the project, or you want to, because she said that she wants to postpone to another time, but I think this is a group work. So if she's not around, maybe the group members can always represent her. Aizat and Zazmizul, do you want
Prof.
her? So you can present her part, right?
Yes, Prof.
Okay. So, okay, now we can start. Maybe our class today is quite short because we only have 2 groups. So I would like group 9 to start presenting their project. Aizat bin Abdul Rahim, Zazmizul bin Anwar, and Afifah Anissa Sofia. Okay, you may share your slide now, and the floor is yours now. Okay, faham. Kelang dan Kuantan. Pahang and Kuantan is are you with group we have group sorry Okay. Group 9, are you going to, do you have the same location with group 4, group 5, Kuantan River? You are doing Pahang River?
Our locality target area is around, Prof. So it's different.
Oh, you are out. Okay. You can start now.
Okay. Okay, Assalamualaikum and a very good morning to all. So we are from Group 9 and today we would like to present our water treatment plan design presentation. Our group members consist of me, Aizat bin Rahim, Jasmine Zulbian Anwar and Anissa Sofia Afifah. Next. So let's discover Pahang River, which is our river location. So it's located at eastern part of Peninsular Malaysia. And it covers area 29,300 kilometers per square. And it is
Sorry,
all.
I forgot to ask you to on your camera so that we can see you. Okay.
Okay, sorry, Prof. Wait.
Okay.
Okay. So now we are moving to the water demand at route. So this is the domestic water demand at route. So according to Department of Irrigation and Drainage 2011, they already forecasting, which is two different area, which is urban potable water per capita consumption and also rural potable water per capita consumption. As you can see, the urban potable water per capita in urban area is more higher than rural. So an average of 190 liter per capita per day is needed for a person who lives in urban, which is the lowest of 176 liter per capita per day is needed for a person that lives in the rural area. So this is institutional and commercial demand. Both commercial demand and institutional demand are projected as a percentage of the domestic demand. So basically, the 20% of the commercial demand in urban area is needed, while 15% in urban area is needed for the commercial demand. And for industrial demand, it's also the same. It is also depending on the domestic demand, which is 15% for urban and also 10% for the rural area for institutional and commercial demand. Next. For industrial water demand, it can be concluded that it is higher than commercial demand, which is Department of Irrigation and Drainage forecasting for year 2020, average of 440 liter water per day is needed for each worker in industrial categories.
Okay, for water Pahang River and source of water supply. So it is divided into the Jelai and Tembeling River, which meet at the confluence near Kuala Tembeling. The Pahang River system begins to flow in the southeast and south direction from the north, passing along the such major town as Kuala Lipis, Jerantut, Temerloh, and discharging at the South China Sea. So the surface water has been developed for domestic and industrial water supply and for irrigation. There are only two small dam reservoir for water supply and irrigation in the vast Pahang River basin. So this is shown for this picture. We can see the Pahang River and also the basin boundary cover. So for the basin has an annual rainfall of about 2,170 millimeter, a large proportion of which occur during the northeast monsoon between mid-October and mid-January. So, and the mean annual temperature at Kuantan is 26.4 degrees Celsius with mean relative humidity around 86%. The river is about 440 km long and drains an area of 29,300 km square, of which 27,000 km square lies within Pahang. So this is the Pahang River and the tributary river and this shown the characteristic such as the length and the catchment area and the highest peak. So for the Pahang River, we can see the length is around 440 kilometer, the catchment area is around 37,000 kilometers square, and the highest peaks is at the Mountain Tahan, which is the 2,187 meter. So for this, according to the HAL Chenxiao 2014, it's known the water quality based on the several parameter. We can see that for AN, BOD, COD, DO, TSS, and pH, we can see the specific value for this parameter. So this is the river classification based on the water quality parameter. So for this parameter, we can categorized this class, which is the class 1 until class 5, from the data that we collect from data that collects for this river. This is the general data. And for class 1, we can see the use is to conservation of natural environment. And for class 2A and class 2B, we can see is conventional treatment is required. And for class 3, we can see we can need extensive treatment required. And for class 4 is irrigation, and class 5 is none of above.
Okay, so we're moving to the water quality of Raups Fraser's Hill. Water samples were collected from 9 selected stations around Raups Fraser Hills corridor. So river water samples were collected about 10 cm below the water surface using pre-cleaned 1 liter high density polyethylene and glass bottles. So there are a total of 9 stations. Next. So this is the map of study location and sampling point. Next. So based on the chemical measurement for surface water, it can be shown that the dissolved oxygen, which is DO levels, in the 3 rivers vary slightly and were in the range of 8.32 to 9.2 magnesium per liter. These levels can be considered saturated in line with the rapid flow of the water. So meanwhile, the TDS, which is total dissolved solids, vary widely within the range of 5 to 23 milligram per liter. For electrical conductivity recorded also have small variation among 3 rivers. Their values were within the range of 23 to 27 micro, and these values were slightly lower than recorded in previous studies. So the BOD and COD obtained were in the range 3.7 to 6.1 milligram per liter and 16 to 66 milligram per liter respectively. Highest concentration was recorded at Sungai Terenum, which is ST1 and ST2. ST1, which was higher than observation in previous study. So other rivers have recorded variation of chemical oxygen demand. And the last one is the TSS, which is total suspended solid fluctuated among sampling station, although within the same river. Next. So this is the water quality index and classification of surface water in 3 rivers. So as you can see that all the station are shown that clean status, except for the ST1 is slightly polluted. So an evaluation of water quality of 3 rivers, which is Sungai Jeriau, Sungai Terenum, and Sungai Tanah Pama, was successfully carried out, and overall water quality index river remain clean and can be used as water supply sources, requiring only conventional treatment system. Thank you.
Okay, thank you, Group 9. Okay, actually, okay, it's a good presentation, but actually, I'm looking for. So, what are the 4 parameters that exceed the guideline that you want to treat? . 。 Remember the instruction. So which are the parameters that need? You can have more than 4, but as required in the exercise, that I need 4 parameters to be treated in your treatment plan. So which one?
The BOD, Prof. COD.
COD, BOD. So what is the BOD required? BOD, COD 2. What else? Actually, they are basically very clean water. They are very clean water. You can see from the dissolved oxygen. So I think for this treatment plant, if possible, actually, I want you to have something that more than what required. Some of the parameters need to be in class 3, so that you need to do extra than what the conventional treatment plant required. So I hope that since you have chosen this river, you know that the last time when I taught you about these coagulants, I hope that you also have something new, not only taking what the conventional process is, okay? Like maybe natural coagulant that you use instead of using aluminum sulfate. Okay? Okay, group
Okay,
9.
Prof.
Prof.
So basically, we have to find a different case study.
Yeah.
So,
So at least your treatment plan is not just the because the conventional one is very simple. Like what we have, if in standard 2, then we only need conventional treatment. Because what I want is some parameters need to be in standard in class 3 or class 4 or class 5. Okay, so it's challenging. It's a bit challenging to you to find the different treatment units. Okay. Okay,
Prof.
thank you, group 9.
Prof.
Okay, thank you, Prof.
You're welcome. Okay, now we have group 10. Muhammad Ashraf bin Abdul Salim, Ahmad Lukman Hakim bin Ali Ahmad, and Sio Min Sio Kyo Kyo. Is it correct, my pronunciation?
I am 서민석.
How do you pronounce it?
서민석.
So Minto. Oh, S. You need to pronounce S as T. Minto.
서민석.
Minto. Okay. Minto. What does it mean?
서 is my family name and 민석 is shining treasure.
Okay. Okay, group 10. You can start now. Minto.
Hello, I am 서민석 who will present about the Han River. Han River is located in the central part of Korean Peninsula. The North Han River and South Han River meet in 양수리, 양평군, and 경기도, passing through Seoul Special City and entering the Yellow Sea from the Gimpo Peninsula.
Okay, thank you, Group 10. Ahmad Luqmanul Hakim is not around, eh? No, I mean he's not in the class. Oh, so he quit, eh? Oh, okay. So he's your group member, eh? I think you should know. But you discuss with him for this river. Okay. Okay, good. Group 10. Okay, actually, Group 10 it's very interesting because it's different location in Korea. But then still the same with Group 9 that you have chosen the river that is already a good water source. It's a good water source because it's very clean. Beside that, only that water quality data for Korea is quite different. That we have this total hardness, total dissolve solid. You know, this is the standard by Korean government, right? So it's a bit different because the water, even the river water, they don't have this COD, BOD. You don't have this standard in Korea for your COD and BOD. The government, meaning that you never, okay, you really control your water source and you don't even expect any pollutants from COD and BOD from organic, from industry. So meaning that the water source is separated from the river is separated from the industrial and any industrial zone or whatever, because they just separate this river, Han River. They really protect the water basin, not the land use should only be for water water source. Is it true? Oh, okay. So it's a different thing. That's why we cannot, like in Malaysia. Sometimes you have to stop the operation because you got pollutants, because the land use, the industrial land use. They also have industrial and commercial sites near the river bank. Okay, so it's different things. So that's why when you choose Korean river, you cannot get a polluted river to be treated for potable water. So I understand that. Okay, then you have to only treat the turbidity. You only have to treat the turbidity. And the manganese and chloride also, it's in the standard, but this one also comply. Okay, so turbidity, yeah, so I cannot do, so this is what they only have turbidity. So your parameter that need to be treated, only turbidity. Even if you do very simple treatment, you can already drink the water. Total hardness. Okay. Okay then, because this is a different sites that is different from Malaysia, so I cannot ask you to get polluted river to be treated for your potable water. Okay, I understand that. So your per capita use is 300 something in Korea? It's double. 305 liters. Why? Water per capita? Oh, maybe because your home, you have everything like dishwasher. Is it true? So, is it true that every household, they have this, not only washing machine, but dishwasher, everything? Is it true?
Yeah.
Oh,
Yeah,
no wonder.
true.
No wonder. That's why the per capita usage is very high compared to us. You know, in Yemen, it's like 60 liter per capita. That is the water usage. In Malaysia, 100 and what? In Malaysia. In Malaysia, 220, right? Per capita. So in Korea, 305. Okay, I think that's all. I hope that you also try to find a new technique, yeah, for your water treatment plant, so that you'll be able, maybe something like, I know that it's expensive, but you can try maybe membrane, so that it's different from what you have in your country, the conventional treatment. Okay. Thank you, Group 10. So I hope that any question that all of you wants to ask about this design, because finally we will have your final presentation for all the, we only have 2 presentations, this one and also the final one. Hopefully we can have the presentation face-to-face at the end of the course, okay? So regarding the last time, actually I sent different academic calendar to our Korean students, because they are not familiar with our school, with our any breaks or holidays in Malaysia. But I send them different from what recently we received from the university, that next week is the actually it's not it's a Hari Raya break, since our class is on Monday and Tuesday, so there's no class. And then the following week will be the mid-sem break. So actually we will have the mid-sem break, and then we continue, and the mid-sem break that I've already scheduled in your timetable will be moved forward. So your mid-sem break is after the Hari Raya break. Okay. So actually we don't have class for 2 weeks, and then we start our lesson as usual. Okay. Any question? Any question? Okay, I think our class is finished. So I'll see you 2 weeks from now. Okay, happy Selamat Hari Raya to all Muslim students, and happy holiday to from those who are not non-Muslim students. Okay. Okay. See you. Thank you.
Thank you, bro.
Thank you, Pak.
Welcome.